Hello, everyone. This is Mrs. Hayes, and welcome to Note 6.2, Quadratic Functions in Context. So this is all the stuff you learned in 6.1, but now you're going to have real-world applications, and it'll be so much fun. I hope you can hear me loud and clear. I'm using a little bit older technology than Mrs. Ruscio does, so I hope it's easy to understand. I'll talk as clearly as possible. The question number 1, the height of an object that is traveling through the air can be well modeled by a quadratic function that opens downward. An object is fired upward, and its height in feet above the ground is given by this equation, this function, where the input t is the time in seconds. So we got height in feet, time in seconds that the object has been in the air. All of this information agrees with the picture they set up for me. Time in seconds is on the t or x axis, and height in feet is on the y or h of t axis. Because using your calculator, graph the object's height for all times where it is above the ground, at or above the ground, and show your table of values. So I've already done this with my graphing calculator. And let me go back to page 1 because that's where it is. Let's see if I can just hit it here. There we go. So this is just enter the equation, and this is the original picture that I got. I'm going to use menu, trace, and see all the wonderful stuff that I find by using trace. Graph trace. The very first point it gives me is 0, 80. So looking at my table of values, 80 goes here. On my graph, 0, 80 is my first point. So I didn't make a table of values. I just wanted to show you that you can find these things by tracing. Hit the right arrow. I'm tracing. Oh, it goes crazy on me. Of course, that's because I'm recording and trying not to make a long video for you guys. So let me just back that up. Well, this is an interesting point, 50. I think I'll record that while I'm there. 50. If I keep going back to the left, slowly without making it jump around, oh my gosh. I did this before I videoed, and it went perfectly well. All right, so this point's interesting too. 2.1, oh, wait a minute, is that really the maximum? There it is. It says maximum when you hit it. Did you see that? It was there. 2, 144. So at 2, it reached a maximum of 144. So those points are interesting. I think we'll find them very interesting in a minute. I'm going to do Control T, and I'm going to look at the table of values. So Control T, there's my table. 1, 128. I need 3, 128, and 4, 80. And then it says I want to go all the way to 6. So watch it jump on me again. Oh, yeah, it did. So let's see, 6, if I just go down, it was negative something, and I'm going to pretend like I know what it was. It was negative. That means it went below the ground at that point. What was the initial height of the object? So let's see, 0, 80. That means it was 80 feet high was the initial height. What's the maximum height? If you look at the pattern in the table, or if you look at the word maximum that was on my graphing calculator a few seconds ago, at 2, it was at 144. So the height was 144 feet. 144, that's feet, by the way. That's what that little tick mark is. So let me plot a couple of these points. At 1, it was 128. That would be about right here. At 2, it was 144. That's about right here. At 3, it is back down to 128. At 4, it's 80. It's very symmetrical. At 5, it's down to 0. And at 6, it was negative something below the axis. So here's my graph. You should be able to plot those points and graph that also. If you need to stop the video to do that, no problem. At what time does it hit the ground? Well, the ground is right here when the height is 0. So that was at t equals 5 seconds is when it hit the ground. And over what interval is the height increasing? That means I'm looking for a positive slope. And the interval is going to be t or in this case, it's like x values, right? So I'm looking for an interval that it's increasing. It looks like it starts increasing at 0 seconds, and it increases until it turns around up here at the maximum, which was at 2 seconds. So from this time to this time, it is increasing down on the x-axis, 0 to 2. After that, it's decreasing and the slope is negative. The expression negative 4t squared plus 50t plus 2 represents the height in meters of a toy rocket t seconds after its launch. So t seconds, this whole thing represents the height. What's the initial height? That would be when t equals 0. So we don't need to graph this. We could just put the 0 in for t, square it, 50 times 0 plus 2. And what you're going to find out is all of this is times 0 and all of this is times 0. And you're left with 2. So when t equals 0, the height is 2 meters. That's choice 2. Number 3, a model rocket is launched from ground level. Its height, h, above the ground, meters above the ground, is a function of time. Here's another function for you. This time they just said h. It's the same thing as saying h of t. What would be the maximum height to the nearest meter attained by the model? When I see the maximum height and I see this negative quadratic, I think I am looking for this point right here. So why not look at a graph real quick and let's see. Oh, look at it, it's still acting up on me. Isn't that fun? So let's go to page, was it 4 that I entered this? Let me just check, negative 4.9, yep. So on this graph page, I entered the graph, and if I hit menu, trace, and I just go to graph trace and use the right arrow, I should, oh, it's doing it again. I should be able to hit the right arrow and find the maximum of the graph. So if I keep hitting the right arrow, I can tell that it's climbing up the left side of the parabola. It's getting closer to the maximum. One more touch. Did it say maximum yet? Nope, there it is. 7,240 is the point down here. So at 7,240, it reached a maximum. Now, do I want the 7 or the 240? It says the maximum height. So it was 7 seconds, 240 meters. So the maximum height is 240 meters. Turn the page, question 4. A swim team member performs a dive from a 14-foot high springboard. The parabola below shows the path of her dive. What is the equation of the axis of symmetry? So looking at this maximum point, the parabola is symmetrical, and that is a 3 right there. So that vertical line has the equation x equals 3. X equals 3 is the equation. Vertical line cuts it in half. What's the value of y when x equals 6? When x equals 6, go up to your parabola. This y value is 14. 14 is the value. What does this mean in the context of the question? Now I got to look at this graph a little bit. It tells me that at 6 feet distance from the springboard, at 6 feet out from the springboard, yeah, I know how to spell, springboard, the diver is 14 feet height, so 14 feet high. I used all the good words from the graph. State the vertex and interpret its meaning in the context of the problem. So the vertex, that's that maximum point we saw at 3. I'm going to take a guess. This would be 22, so I'm going to say 23 looks like the height there. 323 is the vertex. Interpret its meaning. Meaning at 3 feet out, you could say from the springboard, but he said that just here, so I'm not going to write it again. At 3 feet out from the springboard, The diver is 23 feet high. And I always like to say, oh wait, was it feet? Yes. I always like to say this is his maximum height, or the maximum height. All right. Hopefully you're understanding this. A ball is thrown into the air from the edge of a 48-foot cliff. And if you notice, this cliff is at time 0. So it eventually lands on the ground. So it goes up when you throw it, reaches a maximum, comes back down, hits the ground when the height is back to 0. No labels on this graph, but I'm thinking this might be time along this axis, and I'm thinking this might be height over here. Okay, let's see what it says. Graph below shows the height. Oh yes, there it is, of the ball. X seconds, yep, that's time. For which interval is the ball's height always decreasing? It starts to decrease after it reaches its maximum. It goes downhill. Do you see that on the graph? So this maximum occurs at 2.5 seconds, and then it decreases until I reach 5.5 seconds and hit the ground. So from 2.5 to 5.5 looks like choice 3. Thank you for joining me.